Okay, example number 4. Like read the problem carefully, okay? And they said like 2 kilogram mass, okay, on the spring, and the stiffness is 40 Newton per meter, and which means like the spring coefficient K is 40, and damping constant of the system is 8 square root of 5 Newton second meter, okay? And like, there's some initial condition as well on here. And then like they ask you to find the displacement, which means this is damped free vibration mode, right? So here we go. Since we know about like this model, and we can write the like differential equation for this one, okay? It is m u double prime plus gamma u prime plus k u equal to 0. There's no external force, okay? They said the spring stiffness is 40, which is spring constant is 40. Your k is 40. And there is a damping constant is 8 square root of 5, right? So your gamma is 8 square root of 5, okay? We hold this thing, we can update my differential equation like this one. 2 u double prime plus 8 square root of 5 u prime plus 40u is equal to 0, okay? Now let's talk about the initial condition, okay? And at the the starting point, like initial point, they will pull down 10 centimeter downward, right? Which means u of 0 is 10 centimeter, which is 0.1 meter, okay? Downward means the length of spring is increasing direction, right? That's why it is positive, okay? And what of this one? Like downward velocity is given, okay? So it's like it's downward, which means like it's direction of the stretching out the length of the spring, right? That's why u prime 0 is also the positive value, okay? And all setup is fine. So now we have to work on this differential equation, okay? For my convenience, let me divide by 2 to freeze the leading coefficient. So this differential equation can be written by u double prime plus 4 square root of 5 u prime plus 20u is equal to 0, okay? Then definitely this is homogeneous second order linear differential equation, right? So we can use characteristic. Which is r squared plus 4 square root of 5 r plus 20 equals 0, okay? Quadratic formula, okay? Minus b plus the minus square root of like b squared minus 4 times ac over 2a, that is equal to negative 4 square root of 5 plus a minus square root of 4 squared is 16 and times 5, which is 80 minus 80 over 2. So look at that. Your square root of part is equal to 0, okay? That is equal to negative 4, 5 over 2, which is negative 2 over 5, okay? Which is repeated, right? What does it mean? This is the critically damped motion, right? Okay, now we we can set up the general social proof, right? Here we go. Then my UT, since it is the a repeated solution for characteristic equation, your UT must be this form. A times e to the minus 2 square root of 5t plus bt e to the minus 2 square root of 5t. Is okay? So for my convenience, let me combine like this way. A plus bt e to the minus 2, like that, okay? Then now we have decided the coefficient a and b, right? Let me use the first initial condition, which is u of 0 was 0.1, right? Or we can just write like it 1 over 10, okay? Which was when you plug in 0, then your a is equal to 1 over 10. You understand what I'm saying, right? When you plug in 0, and this part equals 0, and exponential function part is equal to 1. That's why your a is equal to 10, okay? Then we can update my ut like this way. 1 over 10 plus, we still have to find the coefficient b as well, e to the minus 2 and 5, okay? Then to find b, we need to use like second initial condition, which is u prime, right? And to do so, we need u prime is equal to, it must be the product form, right? This part and this one, okay? Let me do the like product related, okay? 1 over 10 prime equals 0, and bt prime is b. First function prime times second function e to the minus 2 5t, and plus, and first function, don't do anything for your first function, times second function prime, which is e to the minus 2 5t, and don't forget the chain, okay? And then almost there, okay? Now, second initial condition, okay? Since the problem said u prime 0 was equal to 2, right? Then plug in 2 in there. I plug in 0 in there. Then this part is equal to 1, right? That's why you have like b only. And plus, this part is just like simply 0. And this part equal to 1. So you have like 1 over 10 times negative 2 square root of 5, right? So this is not plus but minus now. It is square root of 5 over 5 must be equal to 2, right? So finally, your b can be found by 2 plus square root of 5 over 5. It's okay? Now with this b value, we can update my general solution with coefficient, okay? It was, let me see, 1 over 10 plus 2 plus square root of 5 over 5 t, no, and t e to the minus 2 5t. Is it okay so far? Okay. So let me come back to the problem, okay? This is a general solution, okay? So like let me double check the problem, okay? The problem asks you to find maximum displacement, right? So we need a like u prime, okay? Here we go. Second stage, find the maximum. Okay? And we're gonna set that equal to 0, okay? Let me write that outside, okay? And to solve this problem, let me take out common factor, but not all of them, but like, exponential function part first, okay? Then this can be written by e to the minus 2 5t, and big parentheses we need, and 2 plus 5 over 5, and plus, and minus, actually we have to multiply negative 2 square root of 5 minus 5 over 5 minus 4 5, and 5 5 square root of 5 times square root of 5 is 5. 5 over 5 is equal to 1, so it's minus 1. Since I minus take out, plus just 2, That's correct, okay? Okay, here we go. And this is out, okay? Then keep that in mind. Exponential function never be equal to 0. It is impossible. Then only the way to make this whole equation equal to 0 is like this part must be equal to 0, okay? So here we go. So what we have is 2 minus 4, 5, 2t must be equal to 0, and plus your negative part to the right-hand side, 2 is equal to 4, 5, 2 t, then your t must be 2 over 4, 5, 2. This is the critical number, which is a candidate for your maximum, okay? Does it make sense? And then you have to do check two things, maybe there's two ways to check this is maximum, right? How can you do it? You can use sign chart or the second derivative test, okay? But either way, okay? But I can tell you this is truly correct one, okay? Okay, give me 1 second. Let me simplify a little bit more. 1 over. Now it is correct. Perfect form, okay? The maximum value of displacement is u of 1 over 2 square root of 5 plus 1. Okay, just plug it back like this critical value into the your displacement function, which is u. And when you plug it back, it is approximately 0.24 meter, okay, or 24 centimeter, okay.